Questions 11 through 20 on the 2011 Grade 12 AMC 12B. A frog located at xy with both x and y integers makes successive jumps length 5 and always lands on points with integer coordinates. Suppose that the frog starts at 0, 0 and ends at 1, 0. What is the smallest number of jumps the frogs make? So first thing, let's just draw a coordinate plane very quickly and see if we can make this possible. Let's just start with 2 jumps, which is the smallest of the answer choices. So we're starting here, we're ending up at 1, 0, right? So can we make it with 2 jumps? Well, if I go 5 this way and then I go back 5, I'm right back where I started. So obviously that's not the approach. But what is a possible approach is if I go, let's say, 5 this way. So I start at 0, but I go 5 up here. And this is not drawn to scale, but you get the idea. And then I come back down 5 that way. Okay, that seems legitimate. But here's the thing. He always lands on points that have integer coordinates. So I have to make sure that this is an integer coordinate. And I can very quickly tell you it's not. Because since this is an isosceles triangle, if you were to draw a line directly from the top to the bottom, you would see that x coordinate will be a half. So this is going to be a half, and in terms of the x coordinate and some y coordinate, but it doesn't really matter what the y coordinate is because the x coordinate is a half, which is not an integer. So that scenario is not possible. Okay, no problem. Let's see if I can do it in some other way. So my next attempt is with 3 moves. That's the next answer choice. All right, so 3 moves. I can go 5 this way. So for example, I'm starting here, right? So I can go 5 this way, and then I've got to end up at 1, right? So if I want to end up at 1 and I go 5 this way, that means I've got to come back up and down like that. That scenario perhaps could do it. Well, let's see. So I'm going 5 this way and then I'm coming back up 5, because remember every move is 5, and I'm coming back down 5 to meet there. All right, let's label this and see if this works out. From here to here is 5. So that means this is minus 5 right there. And then once I go up and down, I've created another 5, 5 triangle. So that's isosceles. So now I've got to figure out the coordinates of this top point. Well, from here to here is 5, and from here to here is 1. So that means basically from there to there is going to be cut in half. So that's 5 plus 1, which is 6. So that means from here to here is 3. So this is 3. And this is 5, and this is a right. So that's got to be 4, right? 3, 4, 5. So that basically means that we have an integer coordinate for this top guy. It's going to be, let's see here, from here to here is 3. So that means this has got to be minus 2. So minus 2 and then 4. So there we go. The frog is going to start here. This is my first jump, second jump, third jump. So 3 jumps he'll be able to do it and always land on integer coordinates. So number 11, the answer is B. A dartboard is a regular octagon divided into regions as shown. Suppose that a dart thrown at the board is equally likely to land anywhere on the board. What is the probability that the dart lands within the center square? All right, I think that diagram is sufficient. We don't need to draw any other. So because it's a regular octagon, what that basically means is that all of these sides are the same. X, X, all the way around. Now, they have conveniently broken it up into sections. So first, let me just label everything that we know. And then these distances we have not labeled, so I'll just call those Y's. Y, Y. And I think you can notice that there's 4 that are the same, another 4 that are the same, and so on. So the probability that it lands on the center like that is going to be the area of that, which is x squared. And then you have to divide by the total area. So first, in terms of just our x and y lettering, the total area is going to be x squared, which is just this guy. And then you have 4 of these that are pretty much the exact same in terms of their areas. And so that's going to be 4 times xy, because those are rectangles. And then you have another 4 triangles that are exact the same, like this. So those will be, each will be 1/2 base times height, which is y times y. So there we go. This is my probability, but obviously the answer choices are numbers, so we have to do a little bit more substituting in here. And that substitution will come from a Pythagorean relationship in that triangle. So from that triangle, you write y squared plus y squared is x squared, right? And that means that 2y squared is x squared. And if you take the square root, you get root 2y is equal to x. And we can isolate for y, x over root 2. So substitute that in, and we get x squared over x squared plus 4x times x over root 2 plus 4 times a half, which is 2y squared, and 2y squared is just x squared. So instead of writing 2y squared, I'll just write x squared, right? Because this is going to be 2y squared. Okay, so this looks like x squared, and then the x squared we can factor from everything. We got 1 plus 4 over root 2 plus 1. And then the x squareds cancel, so all you're left with is 1 over 2 plus 4 over root 2. That is the answer, but it's not in any of these forms, so don't get discouraged. That happens commonly, where you get an answer, but it doesn't look like one of the answer choices. You just have to, simplify it, rationalize the denominator, stuff like that. Okay. All right, so here we go. Let's see what we can do to get it in that form. So we can multiply top and bottom first of all by root 2 to rationalize the denominator, and that will give me 1 over 2 plus 4 root 2 over 2, which is just 2 root 2, right? 4 root 2 over 2, yeah, which is 2 root 2. And then we have to rationalize this denominator. So 2 minus like that. The top will just be 2 minus 2 root 2. The bottom becomes 4 minus 4 times 2, which is 8. So this is going to be 2 root 2 minus 2 over 4. I just reversed it. And then therefore this is root 2 minus 1 over 2. Root 2 minus 1 over 2. And that is choice A for number 12. Brian writes down 4 integers, w, x, y, z, whose sum is 44. The pairwise positive differences of these numbers is 1, 3, 4, 5, 6, 9. What is the sum of the possible values for w? Well, let's put all of these on a number line and discuss what possible choices we have. Now, this is very helpful. They told us that w is greater than x, is greater than y, is greater than z, right? And they told us that the positive differences are like this. So 1, 3, 4, 5, 6, and 9. Now we don't know which is which. The only one that we can be sure of is the biggest and the smallest. That's going to have the maximum difference. And the maximum difference is 9. So from here to here is 9. That's the only one we're certain of. Now the other ones we have to sort of play around and make estimates. So let's talk about the first one, which is 1. Where can 1 go? Well, 1 obviously is between two numbers because these are all integers. So it's going to be either here or here or here. Well, let's see if we put it here. Let's see what happens. If 1 goes there, basically what that means is that w minus x is equal to 1. That means that one of these, x minus z, has to therefore be 8, right? 9 minus 1. And there is no 8 here. So that means that 1 does not go there. The 1 most likely goes here. If that is the case, that means this and this add up to 8. That is possible because we've got a 3 and we've got a 5. And those are the only two that add up to 8. So that means the 3 goes here and the 5 goes there. But we can also reverse those. That is not the only way to do it. If you have w, x, y, and z, we have concluded that the 1 goes here. But we can reverse the 5 and the 3 like that. So these two scenarios, this one and this one, will give me different values for w, and I just add them up. All right, so let's do that. Let's figure out w. In the first one, my equation will be w plus x plus y plus z is 44. Now w, we just leave it as w, but x is w minus 3. I hope you can see that on this number line. Y is w minus 4, and z is w minus 9. And that equals 44. So adding, we get 4w minus 16 is equal to 44, and therefore 4w is equal to 60, and therefore w is equal to 15. So this is my first value for w. Now we do the exact same thing on this guy here, and let's see what that gives us. Again, w plus x plus y plus z is 44, but this time it's w plus x, which is w minus 5, y, which is w minus 6, and then z, which is w minus 9, and that's 44. So we have 4w minus 20 is 44, and therefore 4w is 64, and therefore w is equal to 16. So we got 15 and 16. The sum of those values is 31, and that is what they're asking for. So number 13, the answer is B. A segment through the focus f of a parabola with vertex v is perpendicular to fv and intersects the parabola in points A and B. What is the cosine of AVB? All right, well, a little bit of definitions. If you have a graph of this form, y is equal to a x minus h squared plus k, the vertex is easily calculated as hk. And the focus, which is a little lesser known to students, is hk plus 1 over 4a. So, for example, if you've got some graph here, and we'll make this straightforward to understand, and we've got some parabola, let's say it goes like this, and obviously the very bottom is your vertex right here, so that's hk. The focus, as you can see from the nature of that coordinate, is going to have the same h coordinate, well, x coordinate I should say. So let me just draw this properly. The focus is right here, this point right there, and that's going to be, in our case, h and k plus 1 over 4a, like this. And this red line is basically the segment that they're talking about, and that, of course, in terms of its equation, is y is equal to k plus 1 over 4a. All right, and this is point A, and that is point B, since that is where the parabola is intersected by that line. So what they want is for you to figure out the cosine of a certain angle, and that's AVB. So A to V to B, because that vertex is being referred to as V. So that's AVB. Well, this is an interesting question. So first and foremost, if you want to find the cos of AVB, keep in mind that because of the symmetry of this diagram, AVB is the same as 2 times this angle. So AVB is this whole angle, but this line cuts that angle in half. So if you multiply 2 times that angle, and that angle, since the focus is being referred to as an F, right? That angle, this is F, this point right here. We can just put that F there if you really want to see it again. That angle is the same as 2 times FVB. So that will help us. Now, if you remember the cos of a double angle identity, it's 1 minus 2 sine squared x, right? So if we implement that rule here, cos of 2FVB, it's equal to 1 minus 2 the sine of FVB all squared. All right? And the sine of FVB, if this is FVB, the sine of that is opposite over hypotenuse. So it's FB over the hypotenuse, which is VB. And don't forget to square that. All right? So let's move forward with doing that. This triangle FVB, I want to draw it a little bit larger because I need to label some things and I don't have much space there. So let me just draw that a little bit larger. And now I can label it F, B, and V. Well, V, I have the coordinates, that's good. And F, I have the coordinates. It's H and K plus 1 over 4A. But I need the coordinates for B. That is very much required. So how do I figure out the coordinates? Well, the y coordinate is going to be the same. It's k plus 1 over 4a because it's just a straight line across. So the y coordinate is the same, but the x coordinate I need. The way to get the x coordinate is I've got to substitute the this into the equation. And if you remember, my equation was y is equal to a x minus h squared plus k. So if I substitute in this for y, I'll be able to get my x. So k plus 1 over 4a is equal to a x minus h squared plus k. The k's cancel. Bring the a down, you get 4a squared is equal to x minus h squared. And you take the square root of both sides and you get 1 over 2a. And therefore x, if you were to just isolate for x, it would be a is equal to 1 over 2a plus h. So it's 1 over 2a plus h. All right. So now we can easily figure out FB and VB. So this becomes 1 minus 2 over FB over VB squared. Well, FB is from here to here, so that's just the difference in the x values. And if you compare this to this, if you subtract this from that, you just get 1 over 2a. So that's pretty straightforward right there. And then I can do FV and then use Pythagoras to figure out VB. It'll probably be a little bit easier. Here we're subtracting the y coordinates, so that subtract this, and that's just 1 over 4a. So this is 1 over 4a, and that is 1 over 2a. So to get VB, I can just use Pythagoras real quick. So VB will basically be 1 over 4a squared plus 1 over 2a squared. And that looks like 1 over 16a squared plus 1 over 4a squared, top and bottom by 4, and that gives me 5 over 16a squared is VB squared, right? So VB, if you take the square root, it would be root 5 over 4a. And there we go. Now we have to just figure this out. All right, let's see. So you got 1 minus 2, square that, and you get 1 over 4a squared over 5 16a squared. And this is 1 minus 2, invert and multiply, 4a squared, 16a squared over 5. Good news is the a's cancel, and you're just left with 16 divided by 4, 4. So 2 times 4, which is 8 over 5. And 1 minus 8 over 5 will be negative 3 over 5. So negative 3 over 5 is my answer, and therefore number 14, the answer is D. How many positive two-digit integers are factors of 2 to the 24 minus 1? 2 to the 24 minus 1. We can factor this 2 to the 12 minus 1 times 2 to the power of 12 plus 1. Now this one we probably can't do much with, so we will just continue with this guy here. This one, of course, I can factor a little bit more. 2 to the power of 6 minus 1 times 2 to the power of 6 plus 1. And then this one we leave alone. This one I think I can factor 2 to the 3 minus 1, 2 to the 3 plus 1. And I think at this point we are done with this system of factoring. So now we just have to look at what the numbers are. This one, well, that's easy. 2 to the power of 3 is 8. 8 minus 1 is 7. This next one, 2 to the power of 3 plus 1, so 8 plus 1, which is 9. 2 to the power of 6 plus 1, that's 64 plus 1, so that's 65. And 2 to the power of 12, 4096, I believe, and then plus 1 would be 4097. Okay, now we got the task of breaking this into prime factors. 7 is already prime. 9, of course, breaks up into 3 and 3. 65 obviously is divisible by 5, and I believe that's 5 times 13. Okay, 4097, and without the use of a calculator, we have to break that up into prime factors. And it is 17 and 241, a very big prime number. So these are the prime factors. Now we have to figure out how many two-digit numbers we can create with these prime factors. Okay, so let's see if we can make a list here. In no particular order, I'll just list them. Let's see here. Well, obviously, these two are already two-digit numbers. So I've got 13, 17. And then if I take 5 times 17, that should do it. 5 times 17, that should make a two-digit number. It does, 85. If I do, I think I'm done with the 17s. Or am I? I think 3 times 17 also. That should give me another one. That's 51. And I think that's it, because if I do 6 times 17, that's going to be greater than 100, and that's not a two-digit number. Now let's look at the 13s, any multiples of that. 3 times 13, most definitely, that would be 39. 5 times 13, that would give me 65. And 7 times 13, I think will also work, because that's 91. And then anything greater than that, I think, would be too big. Now we got to play around with these little guys. So in any particular order, let's just work with the 5s. So 7 times 5, that would be 35. 3 times 5, that would give me 15. And then 9 times 5, the 3 times 3, that would give me 45. So that gives me a few more. And then I think I'm done with the 5s. So the only one left are the 9 and the 7. Well, 7 times 9, that's 63. And I think I can squeeze one more with a 3 and a 7. 3 times 7. That will give me 21. And I think that's it. So how many did I get here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number 15, the answer is 12, which is choice D. Rhombus ABCD has side length 2 and angle B is 120. Region R consists of all points inside the rhombus that are closer to vertex B than any of the other 3 vertices. What is the area of region R? So let's draw a diagram of a rhombus, and then let's discuss this. So here we have a rhombus, and I'll just call this side B. And then this is A, C, and D. And they're telling me that all the sides are equal to 2. Now, they want you to create a region so that if you put any point in that region, it's closest to vertex B. So immediately, it makes me think that I've got to draw a diagonal. Now, that diagonal helps us in the following way. If I'm only on this side, then I've immediately created a region where the points will always be closer to B than D. So I'm always going to be closer to B if I draw my points in that half, I guess, of the rhombus. But that doesn't take care of A and C. What if I draw it here? Yes, I'm closer to B than I am to D, but I'm closer to A. So I've got to obviously create a region somewhere in here where I'm only closer to B. I'm closest to B. And that region is drawn as follows. You've got to draw a line that cuts CB in half, and that is perpendicular, and that touches the diagonal like that. And then you do the same thing on the other side. AB, cut that in half, so approximately here, and then draw a perpendicular. And that region is going to be my region R. So this region right here, that is R, because any point that I draw in here is closest to B than to any other vertice. And I hope you can see that. Here, no, it's closer to A. If I draw a point here, it's closer to C. But if I draw a point anywhere in here, it's closest to B. So that is the initial setup of the question. So I've got to find basically the area of that region, and I'll call that region, of course, R. So how do I do that? Well, a couple of strategies. To find R, I'm going to first find the area of half of the rhombus. So that will immediately just give me that much. And then from that, I will subtract these 2 triangles. And because of the symmetry of these triangles, those 2 triangles are identical. So I'll just call them P. So what I'm doing is I'm taking the area of the rhombus, and then I'm dividing by 2, and that's going to give me this guy. And then I'm going to subtract from it 2 times P. And that should give us the region R in terms of its area. Okay, so let's work with this now. Let's concentrate first on trying to figure out the area of the rhombus. Now that can be figured out with diagonals, as I'm sure you know. The area of a rhombus is calculated as follows. It's the first diagonal times the second diagonal divided by 2. Okay. Well, this piece of information is helpful. That's 120. So if I draw a diagonal, this whole thing is 120. So it cuts it into half. So it becomes 60 and 60. All right. So that's the first thing. And then this angle is also 120, right? It's a rhombus. So because of the symmetrical nature, this part behaves identical to this part. So that is 120 also. So that means when I cut it in half, this becomes 60 and that becomes 60. So if this is 60 and that's 60, then obviously this is 60. So that's an equilateral triangle. So that means this side is equal to 2. So I can just call that D1. So that immediately I figured out is 2. Now I have to figure out this D2. Well, that can be figured out as follows. Since this is 60, if I draw a diagonal, it chops it in half, so that becomes 30 degrees. And then since this is 60 and this is 30, this angle must be 90. And the diagonals of a rhombus always intersect at right angles, so we also know that. So now what we can do to figure out this diagonal is use the 30, 60, 90 on this triangle right here. So if I call this, let's say, D2 over 2, right, which is essentially what it is, that over 2, if I'm comparing it to this side, in terms of the ratio of the angles, and you've done this a million times, is root 3 over 2, right? The ratio of the sides of a 30, 60, 90 triangle. So solving, we get D2 is equal to 2 root 3. So I put that here, times 2 root 3 all over 2, and that is just 2 root 3. So I immediately, in my equation here, I've got the rhombus area, which is 2 root 3, and then I've got to divide by 2 because I only want half of it. Now all I'll have to do is figure out the p's and I'm done. So minus 2 times p, and then I'm done. Okay, so now let's concentrate on figuring out p. Well, p is over here. This is p, and in a very similar way, this is 90, this is 30, and this is 60. So if this is, say, the base for p, this is the height, in a very similar way, we can figure it out with the 30, 60, 90 triangle ratios of the sides. So we know that from here to here is half of 2, because remember, we cut it in half when we drew that line. So b immediately we know is 1. And now we just have to figure out h. H over b, which is 1, is the equivalent of 1 over root 3. And that's it. We got base times height. So p is 1/2 base times height, which is 1 times 1 over root 3, which is 1 over 2 root 3. So there we go, 1 over 2 root 3. And this is going to give us our value for r. So r is going to be, looks like just root 3 minus 1 over root 3. And like before, it's not one of the answer choices, but it's not because it's the incorrect answer. It's just because we haven't put it in the format that they want. So not a problem. We can just figure this out. First, let's just rationalize this denominator. And if we do, we get root 3 minus root 3 over 3. And then we can top and bottom by 3. We get 2 root 3 over 3. There you go. You got it in the form. So number 16, 2 root 3 over 3 is the answer, which is choice C. Let f at x equal 10 to the power of 10x. G at x is equal to the log of x over 10 to the base 10. H at 1x is equal to g at f at x, and h at nx is equal to h at 1 at h at n1 at x for integers n greater than or equal to 2. What is the sum of the digits of h 2001 at 1? F at x is equal to 10 to the power of 10x, and g at x is equal to the log of x over 10 to the base 10. And then we have this formula that is obviously a recurring pattern. So let's start with this, and let's start with h1 and make a table, and hopefully we'll have some sort of a pattern. So first, let's start with n equals 1. When n equals 1, we have obviously h1 at x. And that is equal to, right there, g at f at x. So that means we have to substitute f at x into g. So f at x is 10 to the power of 10x, and we have to substitute that into here. So it becomes the log to the base 10 of x over 10, but x this time is f at x. So we have to put 10 to the power of 10x where the x is. And this becomes the log of, to the base 10, 10 to the 10x minus 1. And then we can put that in front according to log rules. And all you're left with is 10 to the power of base 10. And this is just 1, right? So all you're left with is just 10x minus 1. So put that in here, make a little table, right? H1 is 10x minus 1. Now, they want to eventually figure out H 2001 when x is 1. So let's figure out what it is for these when x is 1. And that will immediately just give me 9. So hopefully there'll be some pattern, and hopefully the pattern will emerge sooner rather than later. Okay, let's continue. Let's do n equals 2. Now we have h2x is equal to. Now we have to use this formula, because that formula was valid when n starts to become 2 or more. So it's going to be h1 times h of 1x, like this. Well, h1x is right here. We just figured it out, 10x over 1. And I've got to substitute that into h1. Okay, what that means is instead of x here, I'm going to put 10x minus 1. And this simplifies into 100x, and then it will be minus 10 minus 1 minus 11. 100x minus 11. So that is h2. 100x minus 11. And let's just figure out h2 at 1. When you substitute 1, you're getting 100 minus 11, which is 89. Okay, so let's keep going. Now let's figure it out for n equals 3. H at 3x this time. And again, that formula is going to be h1 times h2x, like that. Well, h2 we just figured out is right here. So we're going to substitute that into h1, which is right there. So it's 10 times 100x minus 11 minus 1. And this gives me 1000x minus 110 minus 1, so minus 111. So that's h3x, which is 1000x minus 111. And then if I put x equal to 1, I will get 1000 minus 111, which is 889. Okay. I think I can see a pattern here, but let's just do one more, just in case you're not sure. Let's just do n equals 4. So that would mean h4x is equal to h1 times h3 this time. And remember, all we're doing is just using this formula right here. And this would mean you have to substitute this guy into this guy. So that would mean 10 times 1000x minus 111 minus 1. So that becomes 10000. So 10,000x minus 10 times 111 minus 1. So that would be minus 1111. So h at 4x is 10,000x minus 1111. And if I substitute x equals 1, it's going to give me 10,000 minus 1111, which is 8889. So I think at this point it's sufficient to stop, because we can easily see what the pattern is. And the pattern basically means that for any n, if you were to substitute 1 for x, it would be 8, 8, dot, 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 a whole bunch of 8s, and then a 9 at the very end. And the number of 8s is n minus 1. As you can see, when it's 4, it was 3 8s. When it's 3, it was 2 8s, and like that. So our task, if you remember, was to figure out h at 2001 1. So that would be h 2011 1, and that will be a whole bunch of 8s, and then a 9. And the number of 8s that we have is n minus 1. So if n is 2011, it'll be 2010 of those 8s. And our task in this question is to figure out that number and then find the sum of the digits of that number. So that number is obviously a big whole bunch of 8s with a 9 at the end. And we don't obviously need to write it all out, but we just need to know the sum of the digits. Well, you're going to have 2010 8s, and then you're going to have 1 9 at the very end. So 2010 times 8 plus 9 is 16089. So that is the sum of the digits of h 2001 when x is equal to 1, 16089. And therefore the answer to number 17 is B. A pyramid has a square base with side of length 1 and has lateral faces that are equilateral triangles. A cube is placed within the pyramid so that on one face is on the base of a pyramid, and its opposite face has all its edges on the lateral faces of the pyramid. What is the volume of this cube? Of course, we will need a diagram to illustrate this. And here is such a diagram. This perfectly summarizes what the question is talking about. So let's start labeling some things here. I'm going to label the side of the square as x. So that is, of course, not just a square, but it's a cube. So it's x all around. This is x and so on, right? They're all x's. Now, what I'm going to do is try to create a strategy first of how am I going to figure out the value of the volume. Well, the volume, of course, is just going to be equal to x cubed, right? The volume of a cube is x to the power of 3. So if I figure out the value of x, then I'm set. But how am I going to figure out the value of x? So I have to create a strategy. And the strategy is as follows. I'm going to draw this diagonal all the way across. And then I'm going to use this triangle to create a Pythagorean relationship. And it's this one right here. That one right there. Let me draw it again here. It's this triangle right here. That triangle will allow me to figure out the value for x. Well, first I've got to figure out what is this and what is that. Well, first let's look at this face right here. I'm going to draw it flat to get a better understanding of it. And this represents, of course, this face right here. All I did was I took this face and I just put it flat here. And then this side of the cube, it touches that face according to the question. So we can draw that in, so it's approximately here. Now, what that does is, in a very interesting way, it creates another equilateral triangle. The big one is equilateral, but because this side is parallel to this side, this also becomes a smaller equilateral triangle. So since I had labeled this as x, this is also x, and this is also x. Now remember, the sides of the this pyramid right here, these guys, they're equilateral. And they told you that the base has a length of 1. So that means those sides have a length of 1. So this is 1, this is 1, this is 1. So that means the distance from here to here is 1 minus x. And that takes care of this guy right here. That's 1 minus x. Okay? So we got 2 pieces of the puzzle so far for this Pythagorean relationship. Now we need to concentrate on this right here. You have to give that some sort of a value. Well, that's why I drew the big long diagonal. The good news is that this is 1, this is 1 as I have labeled. So that diagonal can be easily calculated using Pythagoras, right? Because that's basically just a right angle right there. So that big diagonal is going to be 1 squared plus 1 squared is equal to d squared. So d squared is 2, d is root 2. So that big diagonal is from here to there. But I don't want that whole thing, I want just from there to there. So what I have to do is figure out this diagonal. Well, no problem, this is x and that's x. So the diagonal in that cube from there to there, in a very similar way, let's just call that small d. This guy is small d. Squared is x squared plus x squared. So that means d squared is 2x squared. So that means d is root 2x. So to get this distance, it's basically my big D minus the small d. That would give me the distances from there to there and there to there. But I need to only use half of that. So I divide by 2. And that will give me this distance right here. So let's see, what does that give me? It's root 2 minus root 2x all over 2. So it's root 2 minus root 2x all over 2. So there we go. Now we've got enough to figure out the Pythagorean relationship using that triangle. So it's going to be root 2 minus root 2x all over 2 squared plus x squared is equal to 1 minus x squared. Okay. So this is what's going to help us solve for x. As soon as we solve for x, we can then substitute it back into the volume formula. So we just have to do the algebra now. This is going to be 2 minus 4x plus 2x squared all over 4 plus x squared. And then this is 1 minus 2x plus x squared. So the x squareds cancel, and this is just going to be, if I multiply through by 4, it'll just be 4 minus 8x is equal to 2 minus 4x plus 2x squared. Put everything on one side, and if you do, you get 2x squared minus, or rather adding 8x to both sides, so this becomes 4x, and this becomes minus 2. And then I can divide through by 2, and all I'm left with is just x squared plus 2x minus 1. We need to do a quadratic, so that's minus 2 plus or minus the square root of 2 squared minus 4ac all over 2 times 1. And this is minus 2. That looks like root 8, and root 8 is just 2 root 2 all over 2. So in the end, you just have minus 1 plus or minus root 2. Now we can reject the minus part of it because x represents a distance, so just use the positive one. Minus 1 plus root 2. That's my x. So now all I have to do is plug it back into this volume formula, and I can get my volume, knowing that x is minus 1 plus root 2. So volume is equal to x to the power 3. So that's root 2 minus 1 times root 2 minus 1 times root 2 minus 1, like that. So that's 2 minus 2 root 2 plus 1, root 2 minus 1, like this. 3 minus 2 root 2, and we got root 2 minus 1. Again, multiplying this all out, we get 3 root 2 minus 3 minus 2 times 2, so minus 4, plus 2 root 2. So in the end, we got 5 root 2 minus 7. 5 root 2 minus 7, and that is, for number 22, choice A. A lattice point in an xy coordinate system is any point xy where both x and y are integers. The graph of y is equal to mx plus 2 passes through no lattice point with x between 0 and 100 for all m such that m is between 1/2 and a. What is the maximum possible value of a? So let's draw a graph and discuss this. So let's concentrate obviously on this equation y is equal to mx plus 2. And they've given me some parameters that m is got to be greater than 1/2 and less than a. And we are in search of a. Well, let's first look at that part of the inequality. M is greater than 1/2. So I can compare my graph to 1/2 x plus 2, knowing that m is greater than that. So this can easily be drawn. Draw a couple points. When x is 0, y is 2. When x is minus 4, it will be 0. So and then connect those 2 points, and we get yourself a nice line that goes like this. Now, what's interesting is that if we have this, and m is greater than 1/2, and we draw that line, obviously the line will be above. So it will be something like this or something like that. In particular, in that first quadrant. Now this question is specifically talking about lattice points, right? Points that are integer in terms of their coordinates. So for this interval of x, let's talk about the lattice points for any such value of x. So for example, in this graph we've got 2 and 3 labeled. So let's just use those 2 points. Now, when x is between 0 and 100, we want to find lattice points. Now, I have already drawn this graph, that line I should say. Now I want to concentrate on some value of m. Now, let's label this. When x is 2 on this line, you're going to have 3. So this point right here is approximately 2, 3, right there. And this is 3. So this is 2, 3. And then when x is 3, this point approximately is going to be 3 for the x-coordinate, and then about 3.5 for the y-coordinate. So this is 3.5. Now, the lattice point directly above the line is what I'm interested in. And there's 2 scenarios. The first is I'm going to talk about when x is even. And of course, the second scenario is when x is odd, the value of x. Well, let's see. When x is even, for example, 2, the very next lattice point has got to be right there, which is a coordinate of 2 and 4. Now, in terms of my x, if you look at it from the perspective of that line, it is x, same x coordinate, but how did I get y? Basically, x over 2 plus 3. So as you can see, when x is 2, it's 2 for the x coordinate, but then it was 2 over 2, which is 1, and 1 plus 3. And that's how I got that 4. And then when x is odd, the point right above the point right here would have the following. It would be right here. And that is approximately, what, 3, 4, right? That's the first lattice point directly above our line y is equal to half x plus 2. And in terms of x, it is going to be x, but x over 2 plus 5 over 2, 2.5. So as you can see, when x is 3, it becomes 3 over 2 plus 5 over 2, which is 8 over 2, which is a 4, value of 4. So that is going to be very helpful to figure out slopes, and slope is basically what m is. So what that means is that these lines represent the following. The first one is a line that has a slope that kind of goes through there. And the other one is a slope that kind of goes through there. The line goes through those two points. And each of those has a slope, which we can call M. We can call this M1, we can call this M2. And that will help us. So first, let's figure out the slope for L1, this line right here. We can call this L1. And then this one we can call L2. So the slope for L1, rise over run, and that's just going to be x over 2 plus 3 minus 2. I'm just using this point right here, 0, 2, because it's common to all those, because the equation is there. So that's obviously going to be the intersection point. So x over 2 plus 3 all over x minus 0. And that's going to be x over 2 plus 1 over x. And this looks like 1/2 plus 1 over x. And this is when x is even. That's the slope right here. So I can call that M1. Now in the very same way, figure out the slope for L2. That same thing, rise over run, x over 2 plus 5 over 2 minus 2 all over x minus 0. This is x over 2 plus 1/2 all over x, and when you simplify this, it becomes 1/2 plus 1 over 2x, and that's M2, and that is when x is odd. And now we can figure out the minimum and maximum values, or really we're just interested in the minimum value of m, because we want to ensure that m is as close to 1/2 as possible. So let's figure this out for this guy and for this guy right here. When you have x between 0 and 100, the minimum value of m1, which is right here, it will occur when x is 100. And therefore, if we just plug that in, it'll be 1/2 plus 1 over 100. And if you multiply top and bottom by 50 here, it becomes 50 plus 1 over 100. And that is, of course, 51 over 100. So that takes care of what happens when x is even. Now, in the very same way, we want to find the minimum value of m2. And that occurs when x is equal to, obviously it's got to be an odd number, so 99. Because remember, because of the nature of this, the minimum value will occur when x is as large as possible. And because in the second scenario x is odd, the largest odd number in that range is 99. So you substitute 99 into that formula, you get m2 is equal to 1/2 plus 1 over 2 times 99. And if you multiply top and bottom over here by 99, you get 99 plus 1 over 2 times 99. And that gives me 100 over 2 times 99, which is just 50 over 99. So those are my two possible slopes, and therefore we can conclude that y is equal to mx plus 2 contains no lattice points when m is less than this, less than one of these. Now, we know it's greater than 1/2, but which one do we choose? Do we choose 50 over 99 or 51 over 100? Well, you can rank them, right? We want the value to be as close to 1/2 as possible so that m can have this restriction, and that is achieved with 50 over 99. So this is basically our A. And if you go back, that's what they wanted. So number 19 is 50 over 99, which is choice B. Triangle ABC has AB equal 13, BC equals 14, and AC is 15. The points D, E, and F are the midpoints of AB, BC, and AC respectively. Let X not equal to E be the intersection of the circumcircles of triangle BDE and triangle CEF. What is XA plus XB plus XC? Here's a very nice diagram that illustrates all of what has been written in the question stem. And keep in mind that this D, this E, and this F are the midpoints of AB, AC, and BC, as stated. So that means when you draw these lines D, E, and EF, that DE is parallel to AC, and EF is parallel to AB. And that means that this angle, if I label it, say, theta, angle BDE, this one right here, it will be the same as angle BAC, like that. So this will be theta. And very similarly, this angle EFC will also be theta. All right, so that's the first thing. Now we have to talk about the inscribed angle theorem. Angle BDE is equal to BXE. And I will explain why. First of all, where is BDE? BDE is right here. And that's the same as BXE. BXE. Why is that? The reason is because both of those angles subtend from the same 2 points. Those 2 points are BE. If you take those 2 points and draw an angle coming from them, like such as that one, and then you take those same 2 points and draw another angle, and both of those land on the circle, they will be the same size in terms of their length. So these are equal. So BXE, which is this guy in here, is also theta. And in a very similar way, EFC is equal to EXC. So EFC, which is right here, it subtends from E and C, and then EXC subtends also from E and C, and also meets the circle, as you can see, that dashed circle. So that means this angle is also theta. So we can conclude that XC is equal to XB. And XC is the distance from there to there. XB is the distance from there to there. And recall, since E was the midpoint of BC, BE is equal to EC. And XB is equal to XC, so I'll draw those 2 lines to indicate that. Now we move forward and we start talking about the inscribed angle theorem again. And if you notice, this angle right here from there to there is 2 theta, and that is BXC, right, is 2 theta. But then notice this angle, which is BAC, is theta. And since BXC is equal to 2 times BAC, that tells me that X, this point, it must be the circumcenter of triangle ABC. And essentially what that means is that if you draw a circle that circumscribed around ABC, X is the center of that. So for example, that kind of a circle. And you remember that from geometry, that if this is the center right here, this dot, and you draw an angle like this, if it's twice this angle, then that means this is the center. So that's what I meant by what I wrote here. So we are concluding some very important things, because what that basically means is that XA is the radius of that circle, that red circle that I drew. And so is XB, and so is XC. So what they have asked us in the question is to find the sum of XA plus XB plus XC. Essentially boils down to just finding 3R. Right? Because when you add up these guys, XA plus XB plus XC, it's 3R. So I have to find the numerical value of 3R. And if I do, then I've satisfied the question. So that is what we have to do next. We do that by calculating the area of the triangle ABC in two methods. The first method is Heron's. And some of you may remember the area of a triangle is calculated as S times S minus A times S minus B times S minus C, all under the square root, where A, B, and C are the lengths of the sides, and S is the semi-perimeter, or half the perimeter. So in our case, A, B, and C, they were given in the question 13, 14, 15. So S would be 13 plus 14 plus 15 over 2. And that means S is 21. And then if I plug it back into Heron's formula, I get 21 times 21 minus 13 times 21 minus 14 times 21 minus 15. And if you do this whole math here, it becomes 21 times 8 times 7 times 6, all under the square root, and that is 84. All right. Now there's another formula that is lesser known, and that is something we have to use to figure out the actual numerical value of the radius. Now the next formula is lesser known, and here is the description of it, that if you have A, B, and C that are three sides of a triangle, and A is the area of that triangle, the measurement of the radius of the triangle is R over ABC divided by 4A, or A is ABC over 4R. So A is equal to A times B times C over 4R, where A, B, C are the three sides, A is the area, and R is the radius. Well, we know A is 84, so this becomes 84. And then A, B, and C, we know the length of the sides are 13, 14, 15. And the only thing we don't know is 4R, so we just have to solve for this. And when you do, you get R is equal to 8.125. And remember, all I have to do is figure out the value of 3R, and when I do, I get 24.375. And this is the answer to the question. And of the answer choices, the one that it matches is choice C.